Okay, welcome students to our next section on physical and chemical weathering. So in our previous section we had built these rocks up. So now we have all these rocks and it's time to break it down. Just break down, man. Okay? Because even the greatest, mightiest mountains will eventually be broken down into nice flat plains. And the process by which those giant mountains are broken down are known as weathering. Basically, anything that smashes rocks into bits is called weathering. Okay? And there are two types of weathering. You have physical and you have chemical weathering. Okay? Physical weathering is breaking rock into smaller pieces without changing its makeup. So, smashing a rock with hammer, smashing the rock against your head. Actually, that would hurt. But smashing rock with your car. All these things are physical weathering. Okay? Because what you end up with is the same rock that you start with. Beginning and end are same. Okay? So, for example, this video, X smashes rock, rocks in two pieces, still same rock, just now we've got more rock in smaller bits. Now, the first type of physical weathering we'll go over is actually very common. It's called frost wedging. This is Jack Frost's best trick. Okay? So, you've got rock, and that rock, even though it may look smooth, it's got tons of tiny little nooks and crannies. And when the water flows into them, it then freezes. Now, I don't know if you know this, but when water freezes, it expands. It's one of the reasons why it actually floats on water. It's because it expands and it gets less dense. Okay? But when it expands, it increases in volume, and that puts pressure on the rock. And you do this again and again until the rock just splits open. Okay? So here we have a crack. We got water coming in. The water gets bigger. We're not talking about much, only a couple percentage points here, but it gets slightly bigger, forces it open a little bit, then it melts, goes further down, freezes, expands, goes further down in the rock, and over time, this just literally splits rock in half. Now, our second thing, root wedging, because you will see lots of wedgings here, because wedging is how we break apart rock. Very similar to the frost wedging, we have root wedging. Plants, read trees here, grow in the cracks in the rock. Now, one of the things that you might not know about trees are as they grow taller, they also grow fatter. It's kind of like us people. As you grow old, you grow fat. Okay? And as this happens, you got this teeny little sapling. It's bigger and bigger and bigger. And eventually, it will put pressure on the crack that it's growing in. Because remember, trees don't have a choice. They just grow wherever they land. If it's landing in a crack, it will put pressure on the rock till it eventually splits it in half. Okay. And then there's thermal stress. Our first non-wedging physical weathering. Okay. So with this, as things are heated, they expand. As they are cooled, they contract. Kind of the okay. So heat expand, cool contract. Heat expand, cool contract. Okay. And this heating and cooling of expanding and contracting, rocks are hard. They don't expand or contract much, but it's enough to form little cracks. These little cracks, They get bigger and bigger, along with other stuff like frost wedging that causes cracks in the rock. The neat thing about this is it doesn't need much. Now we're not talking necessarily about summer to winter here. Even during the day, the sun comes up, the day gets warm, the rocks expand, and when it gets night, it cools off, they contract, and so on and so forth. And over the eons, this smashes rocks. And it's not just rocks we're talking about here. We even have to deal with this in man-made objects, like bridges. If you've ever seen these things, they look like giant teeth in the bridge. No, it's not that the bridge is going to transform into a giant monster and bite your car in half. Nope. These are actually thermal expansion joints so that the bridge can contract or expand just a little bit so it won't break in half, which is generally bad. Okay? And of course, physical weathering also occurs anytime you smash rocks into each other. Streams, landslides, blah, 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 blah. Smashing rocks equals physical erosion. So what I would like you to do right now is to think about other types of physical erosion, physical weathering that might occur, and write a couple examples in your notes, okay? So pause the video, think about it, and I will see you in a couple of minutes. Okay? Hopefully you were able to think of times when you get like rock on rock action. This is just a small list of it. Windstorms, lightning, because most rocks have water in it. And when the lightning hits the rocks, well, that water turns to steam and it can explode them, literally. Landslides, animals burrowing, meteors. Obviously, it doesn't happen very often, but it does. Another type of wedging, we've got salt crystals, especially just by the ocean, can go into the cracks and over time build up and just split the rock in half. Waves, rivers, glaciers, etc. We're actually going to be talking about glaciers quite a bit. But that's their own note sheet later on. Okay. So we had physical weathering, where the rock that you start with is the same rock that you end up with. And, well, that is not the case with chemical weathering. Chemical weathering is like the opposite of physical weathering. It's kind of like the Mr. Hyde compared to Dr. Jekyll. Jekyll and Hyde here. So, with chemical weathering, we take rock apart not by just smashing it, but by altering the minerals in the rock. So what you end up with is not the same rock you start off with. So for example, right over here, we've got a rock called granite. I'm sure you've all seen it before. It makes lovely countertops. Okay, and in this rock, we have a mineral known as feldspar. It's kind of like this orangey-ish mineral here. And although granite is extremely hard, that mineral feldspar over time will react with compounds in the air and water and become clay. And clay, well, it's soft. It's slushy. And so will literally just wash right out of the rock. At which point in time, well, with nothing else to hold together, it just literally falls apart, destroying the rock. And that is chemical weathering. One major form of chemical weathering is called oxidation. Similar to if you left your bike out in the rain and it rusted, that's oxidation, but on rocks, okay? Because oxidation is a wonderful element. It loves combining with stuff. which is part of the reason why we breathe it in and use it in our bodies. But it also combines with the minerals in the rocks. In essence, the rocks rust and then can flake off. So that's what happened here. You can see this is what the rock looked like before exposure to the oxygen, and this is it after, and it just flaked off from the surface here. Then we have hydration. Now, this is a second type of chemical weathering using water, although not directly. So what happens is there are certain minerals that love water. They love it so much, they kind of invite it over to their home and it never leaves. Okay? So you have a mineral and it absorbs water and then it gets bigger because there's more stuff in it. These minerals can get up to 35% bigger, and as they expand, of course, they put pressure on the rocks that they're part of and can split them apart. Then there's acid. No, it's not. Now, don't freak out. We're not talking about really strong acids. So this is not the type of acid that will melt your face off. Although I'm sure that if you put a rock in a really strong acid, it would get eaten away as well. However, you don't really see strong acids in nature. They just aren't around. But there is one weak acid that you see a lot, and that is carbonic acid. And that acid is formed when carbon dioxide in the air is absorbed into water, and it forms a weak acid that eats away rocks. That is actually the basis for most limestone caves. So if you go into a cave like the ones in the Black Hills, you see all these beautiful formations that was formed by acid weathering. Guess what happens is the water leaches through the rocks. Because it's acid, it eats away a bit of it. And then when it comes out, it deposits what rock it's dissolved on the outside and moves on. Okay. So cave forming rocks are a type of chemical weathering. Now, I would like you to think back to your mineral unit. There was one particular mineral that we mentioned that reacted with acid. What could that mineral be? So think about it or look it up in your notes. Pause the video and look it up and write in your notes. Okay, did you figure it out? It was, of course, the mineral calcite. Now, this chemical weathering can actually be very, very annoying, particularly when we build our buildings. As you can see here, this lovely little statue. However, due to emissions from our smokestacks and our power plants, we actually form acid rain. And that's a lot more acidic than usual, and it eats away at the beautiful marble here because it literally reacts to it and weathers it away. Okay, so that is chemical weathering or chemical erosion. I will see you next time to continue our breaking down of materials. So if you're feeling destructive, this is the unit for you.